All right, on to question 2. This is about a Bunsen burner heating water in a beaker, changing the water into steam. So explain how the internal energy changes from 20 degrees to 25 degrees. Well, the first thing we've got to do, we've got to show that we understand what internal energy is. So internal energy is the sum of kinetic and potential energy. So the kinetic energy relates to how fast the particles are moving. The potential energy is to do with the bonds between the particles. So if we're increasing the temperature, we are increasing the kinetic energy. So increased temperature leads to an increase in kinetic energy, and this leads to an increase in internal energy. So basically we're saying, yeah, the internal energy goes up because the kinetic energy went up. Looking at this one, let's run through them. So difference in density between a liquid and a gas. So particles in gas have less kinetic energy, would usually be more, although this is kind of a questionable idea generally, but in general, you know, particles in gas are going to be moving faster. Particles in gas have more potential energy. That sounds good, like the molecules are more spread out, so there's more potential energy between them. You know, there's been energy put in to separate them, so they've still got that energy as potential. Particles in liquid are further apart than particles in gas? Definitely not. And particles in liquid are larger than particles in gas? No, not necessarily. And therefore, this is our correct answer right here. We're measuring the mass of boiling water turned into steam in 5 minutes. Estimate the power output of the Bunsen burner in watts. Okay, so here's how we're going to go about this. It's all about equations here. Use the equations, and then you can see exactly what you need to do. Power is the energy supplied divided by the time taken. But if we're turning water into steam over 5 minutes, then we know that the energy we put in is actually M times L. Now, is it L of fusion or vaporization? Well, we're going from water to steam, so it's L vaporization divided by the time. So let's think, can I actually figure all these things out? Well, if I know the mass of the water, then that's good. The latent heat of vaporization of water, okay, if I know that, I can go on Wikipedia and find it out, that's okay. And then the time, well, yeah, sure, I know the time. The time is 5 minutes here. Now, the one thing to be aware of is that time, if we MLV, the time is actually not 5 minutes, it's 5 times 60. Because we actually need it in seconds, right? We want our power to be in watts. That means we need to be in joules per second. And so this number down here needs to be in seconds. Basically, that equation gets you the full 4 marks. You might want to put a little bit of text in there to explain what you're doing in the same way I have done as I'm talking. But that is the principle. If you measure M, L, and T, you can get the power of the Bunsen burner.